All right, welcome back to episode 48. Today we're going to do something maybe just a little bit different than what we've done before, but we're going to solve an actual problem. In this case, we're going to solve Euler number 1. And basically, I've got a description of it here, but if we list the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, 9, and if we sum those, we get 23. But what we want to do to solve this problem, we're going to do that for all the multiples of 3 or 5 that are below 1,000. So it's quite a bit bigger, but it really isn't going to make that much of a difference. So what I want to do is to talk about how would we, in a functional manner, solve this. So the first thing that is clear by reading this is that we're going to need to know whether something's a multiple. Well, knowing whether something's a multiple is very, very easy. We're going to take two arguments here, and we'll do x modulo y, and if that equals 0, then it's a multiple. And then the other key things are the multiples of 3 or 5. Well, we can very easily encode that into another function, which basically uses is multiple and passes it the values of 3 and 5. So if we look at 3 or 5 multiple and we pass 15, then that's true. If we pass 12, that would also be true. Because it's a multiple of 3. It's an or, not an and, which matches what our problem is. So we're kind of building up a little bit bigger thing by using a smaller function. Should be pretty simple so far. So now one of the things that we need to know is we need to be able to list, because we have to list all the natural numbers below a value. Well, so I have this little function here, numbers below, and this, truthfully, I'm not real happy with that. JavaScript isn't really doing us a lot of favors here from what I can tell. Other languages would allow you to just do open close brackets and then, dot dot 1 or whatever. But regardless of the implementation here, the concept is not so much the implementation, it's how we're breaking this idea, this word problem, if you will, from math down into some small little functions. So numbers below, if we pass it an x, what we want to do, we want to be able to pass it a number and then get an array of numbers. And if we look here, if I call numbers below and I pass 10, then I get what we would expect. I'm listing all the numbers here that are below 10, 1 through 9. And so then what we want to do is we want to take that and we only want the numbers that are multiples of 3 or 5. So now that we have our numbers below function, we can then filter that. And so what that allows us to do here, let's tab this so it looks a little bit nicer. We can filter that and we're going to pass it our 3 or 5 multiple that we used up above, which is going to give us only the ones that are numbers that are below 10 that are multiples of 3 or 5. And so we would get 3, 5, 6, 9. And we can validate that now against the initial instructions that we had, and it says that if we perform that for the numbers below 10, we get that are multiples of 3 or 5, 3, 5, 6, 9. So we're still valid here. So we're filtering that, we get 3, 5, 6, 9. And then what we need to do is we actually need to take the sum of those. So what that means is that we can still do solve. We're still going to pass in this x, so we get our multiples below. And then what we can do is we can basically just reduce this, which is using, if you remember our vocabulary word, we're using a catamorphism here to reduce, and we're just basically going to sum those things up. And if we solve for 10, then we get 23, which is exactly what it said we should get for 10. And then if we wanted to do it for 1,000, we could just call solve with 1,000, and this would be the number that we would get. So there's a lot of different ways to go about solving this problem. This is just one way of doing it. There are the details kind of really matter as far as how you want to do it. From the standpoint of, in this case, we're filtering and then we're reducing. Sometimes I've chosen to pass in a function. Sometimes I've chosen to still take this x and pass it through. And the reason that I did that was because I knew that solve, we wanted to do our tester, which is 10, which we knew had to match. And we also wanted one that was the actual value to get what we're actually trying to solve for. So there's a lot of different ways of playing around with this. This one does suffer from the fact that I'm filtering, which means I'm iterating through all of those numbers, and then I'm reducing, which means I'm iterating through the filtered version of those numbers. So it's not as performant as it could be. There's lots of different ways to do it, but I think the reason that I showed it the way that I did was to show how we can take something like this that's much more of a use case, break it down into some small functions, and then kind of squish all those functions together to be able to actually solve something. So if you've got another cool way of solving this, Euler number one, or you want to get into solving some of these Eulers, that's how I actually got into a whole lot of functional programming and learning about things like map and filter and reduce and stuff on arrays with numbers. Post your comments and let's I don't know, maybe some vote on them, or we see some other cool ways of solving some of these things. So there you have it. That's episode 48, solved Euler, purely functional, although probably not anywhere near as efficient as we could have it, but definitely much more descriptive as far as defining each small little helper function as we went along the way. Hope you enjoyed it.